Hey, I'm Jordan. Have you ever thought of how mountains were formed? Mountain formation is a consequence of large-scale movements of the Earth's tectonic plates. As two plates collide, the Earth may fold and give rise to huge mountains. In fact, this is the way the Himalayas were formed 50 million years ago. The Indian plate collided with the Eurasia plate, and the world's tallest mountain range was born. The force behind that extraordinary collision is called momentum. This force doesn't only govern natural processes, it also acts upon our everyday lives. In fact, more an object has momentum, harder it is to stop. Think of an American football match. A player of the rival team weighing 120 kilograms is running against you at full speed. You don't need to be a scientist to understand he will be hard to stop. The reason is because he has momentum. Both the earth plates and the footwear are driven by the same force. Momentum, of course. In physics, this is defined by the quantity of motion that an object has. If an object of a given mass is moving, then it has momentum. As seen in this equation, the momentum of an object whose symbol is lowercase p is equal to the mass of the object times its velocity. This says that momentum is directly proportional to an object's mass and its velocity. Thus, the usual metric unit of momentum is kilograms times meter per second. If a goalkeeper has to stop a ball flying at 70 km per hour, he will need to make a certain effort. If that ball flies at 140 km per hour, he will need to make a much greater effort. The higher the speed, the more the ball will push back the goalkeeper's hands, as it transfers its momentum to him. The mass remains the same, but with the velocity increasing, the momentum becomes stronger. Now, a soccer ball weighs between 410 and 450 grams. If the same goalkeeper had to stop a plastic ball, which weighs 200 grams and flies at 70 km per hour, he would need a much less effort than for a soccer ball traveling at the same speed. The reason is, momentum also depends on the mass of the moving object. The lesser the mass, the lower the momentum. A very important law in physics is the law of momentum conservation. It says that in a collision between objects, their combined momentum before and after the collision is the same. That is, the momentum lost by object 1 is equal to the momentum gained by object 2. The total amount of momentum does not vary, but is transferred between the two objects. The way momentum is transferred depends on the type of collision. There are three types of collision: perfectly elastic, perfectly inelastic, and partially inelastic. In a perfectly elastic collision, the two objects that collide immediately bounce off each other. Think of a game of pool. When a ball hits another one, both bounce off. If the second ball, as usually happens, is static, this implies that some of the momentum of the first ball is transferred to the second one. Mathematically, this can be written distinguishing the initial momentum indicated by the letter I and the final momentum indicated by the letter F. If we name the two ball balls 1 and 2, then we have mass 1 times initial velocity 1 plus mass 2 times initial velocity 2 equals to mass 1 times final velocity 1 plus mass 2 times final velocity 2. This equation allows you to see how the momentum lost by the first ball is gained by the second one. A totally different case is when you have a perfectly inelastic collision. The two objects that collide stick together after the collision. They don't bounce off. In real life, this can happen when two cars collide and they are stuck together. How can this situation be described mathematically? The equation remains the same as we have seen before. As two cars are stuck together, they also move together. This means that their final velocity is the same. There is no need to distinguish between final velocity 1 and final velocity 2, as there only is a single final velocity. This simplifies the equation. The third type of collision is a partially inelastic collision. In this case, the two objects that collide first stick together and then bounce off each other. In a way, this is a mix of the previous two collisions, the perfectly elastic and perfectly inelastic, and the equation becomes much more complex. For example, think of a common car crash in which first the two cars stick together for a second and start crumpling, then bounce off each other. The law of momentum conservation still applies, but some energy is lost in the forming process. Friction, sounds, heat are some of the ways that kinetic energy can be lost during a partial inelastic collision. This is actually the most common form of collision in the real world. From human collision to geological shifts, the laws of momentum are very important as they apply to a wide range of things. And as always, thanks for watching.